AI agents are becoming autonomous business analysts. A new Oz implementation pattern shows AI agents using model context protocol servers to gather evidence from business systems and generate autonomous insights. The architecture is more important than the demo. Useful agents need narrow tools, explicit permissions, provenance, evaluation, and a human-owned path from evidence to action. Amazon Web Services published a new technical pattern on July 29 for generating autonomous business insights with an AI agent and model context protocol servers. The example connects an agent to business data and analytical tools, lets it decide which approved capability to call, and returns a synthesized answer rather than forcing a person to assemble every query manually. The headline sounds like another agent demo, but the underlying architecture marks a practical shift. Analysis is moving from a fixed dashboard toward a bounded software worker that can gather evidence, choose a sequence of tools, and explain a result. Traditional business intelligence begins with a person who knows which dashboard to open, which filters to apply, and which anomalies deserve a second query. An agent can compress that interaction loop. A manager might ask why a product category changed, and the system can inspect sales, inventory, support, and campaign data before presenting the most plausible contributing factors. Model Context Protocol provides a standard way to expose those capabilities to the agent, reducing the need to build a different one-off connector for every model and application. That standardization matters because useful enterprise questions rarely live inside one database. Revenue may be visible in an order system, stock constraints in inventory, customer friction in support records, and campaign timing in a marketing platform. A well-designed agent can follow the chain across those systems while preserving the identity of each source. It can ask a narrow follow-up query, compare time periods, and stop when the evidence is insufficient. The business value is not merely a fluent paragraph. It is a shorter, repeatable path from an operational question to inspectable evidence. MCP does not make a connection safe simply because it is standardized. Every server defines tools and resources the agent can discover and invoke. Those definitions become part of the security boundary. A read-only sales summary is different from raw customer records. A forecast is different from an order-changing action. Organizations should expose the smallest useful capability, validate every parameter, separate read and write privileges, and make authorization depend on the user, purpose, region, and current workflow rather than on the model's confidence. The agent also needs protection from instructions embedded in the data it reads. A support ticket, uploaded document, web page, or database field can contain text that attempts to redirect the model. Tool descriptions and trusted policy must outrank retrieved content. Untrusted data should be labeled, scoped, and prevented from silently expanding permissions. A business insight agent should never convert a sentence found in a document into authority to contact a customer, disclose a record, or modify a production system. Provenance is the difference between an impressive answer and an accountable analysis. Each claim should retain the source system, query, time range, filters, transformations, and tool version that produced it. If the agent infers a cause, it should distinguish correlation from verified causation and show the supporting evidence. People need to reproduce the result, challenge an assumption, and see when fresh data changes the conclusion. A confidence score without an evidence trail is not a substitute for traceability. Evaluation must test the workflow, not only the final wording. Teams should measure whether the agent chose the right tools, respected access boundaries, constructed valid queries, detected conflicting records, cited the correct evidence, and stopped when information was missing. Tests should include stale data, schema changes, regional restrictions, prompt injection, ambiguous questions, duplicated records, unavailable services, and cases where the safest output is a request for human review. A polished wrong answer is still a failed analytical process. Cost and latency also become product decisions. An unconstrained agent can issue many redundant queries while exploring a question. Tool budgets, time limits, caching, query planning, and early stop rules keep the workflow usable. The interface should show when the system is still gathering evidence, which systems were consulted, and whether the answer is partial. For recurring questions, a verified workflow can be saved and monitored rather than rediscovered from scratch every time. The most responsible adoption path begins with read-only analysis. Let the agent assemble evidence and propose conclusions while a person retains ownership of decisions. Next, permit narrow reversible actions such as saving a draft report or opening a review ticket. Higher impact actions should require explicit approval, independent validation, and a durable audit record. Autonomy should expand because measured evidence supports it, not because a demo looked convincing. This pattern also changes how smaller organizations can use their existing systems. They may not have a dedicated analytics team, but they still have operational questions spread across orders, inventory, support, and finance. A carefully bounded agent can make those records more accessible without pretending that every conclusion is certain. The competitive advantage will come from trustworthy integration. Accurate connectors, clean permissions, clear evidence, and workflows that return control to people at the right moment. For this edition, Zorg turned the implementation pattern into a literal production map. An operator asks a business question, an agent selects approved MCP tools, separate systems return scoped evidence, a provenance ledger records every step, and a human owner reviews the resulting recommendation. The narration was produced privately with local Kokoro speech. While story-specific 9 stills were rendered through the local Comfy UI workflow on an NVIDIA RTX 3090 at 60 sampling steps. The finished sequence was assembled and verified locally before publication, demonstrating research, narration, visual planning, local image generation, editing, media verification, protected deployment, and exact cross-platform publishing as one controlled workflow. Zorg's conclusion is that autonomous business insight is not one giant model replacing an analyst. It is a governed chain of small capabilities: identity, permission, tool selection, data access, transformation, evidence, evaluation, and human decision ownership. MCP can make those capabilities easier to connect. The organizations that benefit will be the ones that make every connection narrower, more observable, and easier to challenge than the process it replaces. Sources: Amazon Web Services, generate autonomous business insights with AI agent and MCP servers. July 29, 2026. Model Context Protocol Specification and Security Guidance. National Institute of Standards and Technology AI Risk Management Framework. OWASP Guidance for Large Language Model Applications and Agentic Systems.